In this video, we're going to be looking at solution of elliptic equations by relaxation method. Right, consider the Laplace equation, this one that I've ticked there. Okay, so in order for you to be able to solve the problems on the relaxation method, using the relaxation method, first thing first, you're supposed to know how to find the mesh points, the values of the mesh points. Right, in order to find the values of, the moment you know how to find the values of the mesh points, you are good to go. So I'm going to show you how you're going to do that, deriving it from this general equation that we're given there. Right, so first thing first, maybe let's just call this the y and this one the x. I'll explain why as we continue. It helps us to solve our question better. Right, then the partial derivative of u with respect to x, the second one, is approximately equal to, right, is it the x-axis is the horizontal line, and so since we want to find the mesh point u naught, so here I had indicated that u naught, the value of u naught is what is a. So I want to know the value of a, want to know what is a. Right, since it is on the x-axis, we're going to concentrate on the points which are on the x-axis. So from u naught, if you move one step going to the right, you're going to get what? U naught. And then you move one step going to the left, you get what? U3. Then you go back to u naught minus 2 u naught. You divide all of that by h squared, because we're saying that that is the length of our mesh. Right, then we do the same thing for partial derivative of u, the second one, with respect to what? To y. So this one is approximately equal to. Right, so is it we're concentrating on u naught? Let's not forget that. You want to know the value of a, of u naught. And okay, so in this case, since we're concentrating on the y-axis, right? So from u naught, if you move one step going up, we are going to get what? U2. Plus, you move one step going down, you get what? U4 minus 2 u naught. Everything over h squared. Right. So let me call the first one 1 and the second one 2. So from our equation here, these two partial derivatives are adding each other. So that's what I'm going to do here. I'm going to say, Auntie was saying 1 plus 2, 1. So what is 1 plus 2? Is what? It's u1 plus u3 minus 2 u naught plus u2 plus u4 minus 2 u naught. Like, let's not forget our h squared there and our h squared there. So these two are equal to 0, as indicated on top there that they're equal to 0. Right, so we now want to combine these ones. Huh? So what are we going to have? We're going to have u1 plus u3 plus u2 plus u4 minus 4 u naught. We collected like terms then. Everything over h squared equals 0. And then we get rid of the fraction. If we multiply by h squared both sides, we're going to end up having what? u1 plus u3 plus u2 plus u4 minus 4 u naught equals 0. Right, so here anyway, we want to find out what is u naught. How do you find u naught? So what happens here is we're going to bring this 4 u naught this other side, and then we're going to have u1 plus u3 plus u2 plus u4. So what is u naught? So our u naught there is 1/4 of everything. 1/4 of u1 plus u3 plus u2 plus u4. Right, if you go back there to our mesh, u naught, we're looking for u naught, so we're saying that it's u1 plus one step to the right, one step to the left, one step going up, one step going down, minus 4 u naught. Right, so now that we know how to find these mesh points at A, let's try to find at B. So at B, which is u1, so u1 is equal to 1/4 of what? Let's go and check. Of u naught plus u5 plus u6 plus u7. Okay, so it's u0 plus u5 plus u6 plus u7. Right. Once you know how to solve this, you're home and dry. You'll be now knowing how to use the standard 5-point formula. Okay, right, let's solve this equation. This question was given that you're supposed to use the Euler search method to solve this Laplace equation. We're given inside the square bounded by the line. So these are my, what do you call them? These I've already drawn my square, and so it's bounded by the lines x equal 1, x equal 2, x equal 3, x equal 4, y equal 1, y equal 2, y equal 3, y equal 4. So let me just label those ones below here. 0, 1, 2, 3, 4. Same applies here. 0, 1, 2, 3, 4. Right, now I want to find, given that u equal x squared y squared on the boundary, now I want to find the boundary points. We're going to first concentrate on the x-axis. On the x-axis, the value of y is 0. So since y is 0, 0 times anything is 0. So here the boundaries will be 0, 0, 0, 0, 0. Then same applies on the y-axis. On the y-axis, the value of x is what? Is 0. So any value, any number times 0 is 0. So again here, it will be what? 0, 0, 0, 0. Right, then now we want to find the boundary points, the last boundary point on your, on your right, the last one, and want to know those boundary points. So at this point here that I've indicated there, what is the value of x? The value of x is 4. What is the value of y? The value of y is what? Is 1. So 4 squared times 1 is what? 16. Right, going to the next point, the value of x is still 4. So 4 squared times 2 squared, the answer is what? 64. 4 squared times 3 squared, the answer is 144. And then 4 squared times 4 squared, the answer is what? 256. Right, we're not yet done. All right, let me just try to correct that 256 so that it looks, yeah, 256. Right? All right, then we do the same thing here. We come here. What is the value of x here? It's 1. The value of y here is 4. So we get 16 again. Here the value of x is 2. The value of y is 4. So the answer is what? So if you say 2 squared times 4 squared, you get what? 64. Remember, we're substituting this. This is why we are substituting everything. Okay? This is where we're using our x and our y. And then here the value of x is 3. The value of y is what? 4. So we get 144. This one will get 256 again, but won't repeat. 256 is 256, right? Right. Okay. Next thing. The next thing that we are going to do here is we want to find the mesh points. The mesh points which are inside. So let's just call them. This is A. Let's give them names. A, B, C, D, E, F, G, H, and I. Right, so I want to find the residuals at each mesh point. Right, so we're going to find the residual. The first residual that we are going to concentrate on here is right, no. Actually, you want to find the mesh points before we find the residuals, right? Right, so the mesh point at A, there, we're following those steps that I had mentioned on top there. At E, actually. So at E, the value is 1 over 4. We use the 5-point formula where you say 64 plus 60. Right, maybe let me just erase these ones so that they don't confuse, us. We don't want people to be confused. So let me quickly erase these ones. Yes. Once they're erased, then we feel fully concentrate on our question. Okay. Yeah. Good. Right. So at E there, we say what? 64 plus 0 plus 0 plus 64. We start at the center. So 64 plus 0 plus 0 plus 64 is the same as 64 plus 61. So what is 1/4 of 64? 1/4 of 64 plus 64. We are going to get 32. Right, and then next thing, we're going to go and find our value at E. At E, we're going to use what we call the diagonal 5-point formula. So maybe let me just have write my 32 there, so that people are not, we don't leave anyone behind. Then, so we're using the diagonal formula. This is how we use the diagonal formula. We use it like that. Right. So we say 32 plus 0 plus 64 plus 0. So it's 1/4 of 32 plus 64. Right. So what is 1/4 of 32 plus 64? It's 24. 24. That one is clear, right? Okay. So if it's clear, that's good. Right. Let's move on to the next one. The next one is C. At C, again, we use the standard 5-point formula. I mean the diagonal formula, right? 24 there. The same thing that we did there. So at C equal 1/4 of what? Like that. Right. So it would be 1/4 of 32 plus 256 plus 64 plus 64. So 1/4 of all of that, we get 104. Clear. Right, and then we move on to the next one. What will be our next one? The next value is, let's concentrate at G there. Let's go to G. Again, we use the diagonal formula. Like that. Okay, so it's 1/4 of what? If you notice, you're going to get 32 plus 0 plus 32 plus 0. So what is 1/4 of 32? 1/4 of 32 is 8. Right. So 1/4 of 32, we get an 8 there. Right. We do the same thing at I. At I, it's 1/4 of 32 plus 0 plus 64 plus 0. So it's 1/4 of 32 plus 64, which is 24, just like at A. Right, let me just indicate. So we said at A is 24, at C it's 104. At C is 104. Right, at G it's 8. At I is 24. Right. Now that we have these points, it's now easy for us to find the points at B using the standard formula. At B, what will it be? It will be 24 plus 104 plus 64 plus 32. I hope that one is clear. Okay. So at B, we said it's 1/4 of 32 plus 64 plus 24 plus 104. 32 plus 64 plus 24 plus 104, of which we are going to get 56. Right. We do the same thing at D. Right. I'm sure by now you're familiar. You're familiar with how we find our points. So at D is 1/4 of 32 plus 0. Right, 1/4 of 32 plus 0 plus 8 plus 24. So 8 plus 22, 24 plus 32, of which we are going to get 16. Right, 16. Right, we do the same thing at F. At F is 1/4 of what? 32 plus 64 plus 24 plus 104. 32 plus 64 plus 24 plus 104, which is equal to 56. Right. Which one are we left with? We're left with H. Okay, I didn't write the answer for B. The answer for B is 56. Okay. Right. Then we're left with H. At H is 1/4 of what? At H, 1/4 of 8 plus 24 plus 32 plus 0. 8 plus 24 plus 32, which is what? 16. Right. So now that we know the values of our mesh points, we are almost there. Right. Then the next thing, we're going to find the residuals. Okay. So how do you find the residuals? Right. That is another step. So residual at A equal. This is what you do. You go to A, you say, just concentrate on the diagram here. Let's concentrate on the diagram that I've put out so that no one is lost. Right. So, and concentrate on where I am indicating the ticks so that you are not lost. So at A, we're going to say, we're using the standard formula again. So you say 0 plus 56 plus 16 plus 16 minus 4 times 24. Okay, so the residual at A is 0 plus 56 plus 16 plus 16 minus 4 times 24. Let me put a bracket there. So the answer is minus 8. So our residual there is minus 8. Right. Right, okay. So the next thing, maybe let me just use a different color for the residuals. Yeah, so if we use a different color so that people are not lost. So it's minus 8 there. Okay. And then next residual. This one we can find our residuals following our order there. So what do we do for the next residual? We say 24 plus 104 plus 32 plus 64 minus 4 times 56. Right, so you punch that in your calculator. Right, so what do you get there? You get 0. Right, you do the same thing for C. You get minus 16. Here you get D, you get 0. E, you get 16. At F, let me remind you, you say what? Right, you say 32 plus 64 plus 24 plus 104 minus 4 times 56. Right, if you practice more, you'll see that it's not that difficult. So what is our answer there? We're going to get a 0. Do the same thing here, we get a 0. You do the same thing, you get a 0. At I, you get minus 8. Okay, now that we have our residuals, we're not yet done. We identify the highest residual. Like when you're identifying the highest residual, you consider the highest, the residual with the highest, the highest residual. You don't consider the negatives there, and so you just look at the modulus of the functions and look at the highest. So the highest there, maybe let's look at what? At 16. 16 and minus 16 are our highest. Remember what I said is we don't consider the what? The negatives. Right. So what you do is, let's go to E. This is what you do with our residuals. We say 4 into 16 is what? 4. Remainder what? 0. Right. And then this is what you do. This 4, you carry it to the neighbors. Yeah, we put a 4 there. We put a 4 there. Write a 4 there. And a 4 there. Okay. Right, let me repeat myself. So you say 4 into 16, we got 4, remainder 0. And then this 4 is going to be written to the neighbors. The neighbors of E are D, F, B, and H. Then these 4s are going to go under the value of the residuals. Okay. Right. Then the next big value is minus 16. So 4 into minus 16 is minus 4. Remainder 0. right? And then we do the same thing that we did there. It goes to the neighbors. Okay. And then the next biggest residual there is what? Is minus 8. Okay. Right. So 4 into minus 8 is minus 2, remainder 0. Then this minus 2 is going to go under the residuals, the neighborhoods. Minus 2 there and minus 2 there. Okay. And then the next biggest, actually the last one, is minus 8 because the rest of them are zeros. Right. This minus 8 is 24. So 4 into minus 8 is what? Minus 2, remainder 0. Okay. Right. And then it goes to the neighbors under the residuals. So at F there and at H there. Okay. Right. We are done. Then the next thing, now we're writing. So the thing with the residuals is you stop at the smallest residual. That is when you stop the process. So if you check, so far the highest residual that we have so far is what? Is 2. So 2 is very small, because if you say 4 into 2, you get a 0. So we can't continue dividing by 4. So that is why we stop. Okay. So now we're going to write the what? The final values of u. Right. So the final values of u, this is how you get them. You say, so at A, you say 24 minus 2. So it's 22. Then at B, you write it as it is, as 56. At C, 100 minus 4, you get 100. So I'm now writing the final answers. All right. So our final answers will be, right. So at UA, we said is 24 minus 2, which is 22. At UB, the answer is 56. Take it down as it is. At UC is 100, because 104 minus 4 is 100. Then at UD, 16. At UE, right, at UE there, you say 32 plus 4, which is what? 36. Which is equal to 36. At UF, it's 56. At UG, equal 8. At UH, equal 16. At UI, our answer is 22. We are done. Right. So that is how you solve elliptic equations using the relaxation method. It's pretty an interesting way of solving the equation and of solving elliptic equations, and you can also use the relaxation method to solve simultaneous equations. So we're going to concentrate on that next time. Please, if you have any questions, don't forget to ask questions, and don't forget to like, comment, and subscribe. Right, let's meet on the next video.